The first thing that we need to think about today is the difference between what we observe and what we might expect to observe. Okay, so we're going to work with this notion of observed values and expected values. That's always going to be important when we're dealing with statistics, because we always have something out there that's a null model or an expected model, and then we look at the data that we actually get, and we see if that differs from that expected model. Just to have an example to work with to make all of this clear, that I'm teaching a class of 100 students, and in that class there's 30 men and there's 70 women. So that's how the gender distribution is among the 100 students, okay? Now as I'm teaching the class, I give a midterm exam, and I discover somehow that there's been a massive cheating scandal in my class. In fact, I discover from looking at the test that 40% of the class cheated on the exam. And I start wondering, just because I'm looking at the data and I think it looks a little strange, I start to wonder if there's a relationship between the gender of the student and whether or not they cheated. Now what in this case, to go back to our hypothesis testing that we just covered, what is the research hypothesis that I'm interested in? I want to know if there's a relationship between gender and cheating. That's what I want to know. Okay? What's my null hypothesis? My null hypothesis is that there's no difference between men and women in the amount of cheating they did. How am I going to construct that null hypothesis? Well, that's where we get to those expected values. We get to those expected values, and we derive them all from this overall distribution of gender and of cheating in the classroom. So let me go ahead and just talk you through that with a little simple table, a 2x2 table. We love 2x2 tables. They're nice and simple, and they help us understand things very easily. I'm going to have 4 cells, 2 here by 2. That's my 2x2. And the 2 things are my variables. So up here I'm going to have all my men, and here I'm going to have all my women. Okay? And then over here on this side I'm going to have whether they cheated or not, my other variables. So cheaters or not cheaters. Okay? All right. So now I need to just put all my numbers inside this table. Now, what did I already tell you, though, about cheating and the men and the women in the class? I already gave you some information that I know. One is I know that there's 30 men and there's 70 women. So if I go down here and say the total number of men in the class is 30 and the total number of women is 70, right? So those are called my marginals. Those are on the outside of the table. I don't know what's in the middle here yet. I'm going to find that out in a little bit. I also told you that I had determined from looking at the test that 40% of the entire class had cheated. So these are the cheaters over here, okay? And down here we have the people who didn't cheat, the pure of heart. Those are my marginals, and they add up to 100. Either way, I add up. I got 100 total students in the class, 100 men and women together, and 100 cheaters and non-cheaters together. I have 100 total N in the class. Okay, so now, based on this, I can construct my expected values. Expected values are within each one of these categories. How many cheaters should I have? If I have 40% of the class cheating, then if there's no relationship, if there's a null relationship between cheating and gender, then that means I should have the same percentage of men and women cheating, right? So if I've got 30 total men and 40% cheating, my expected value, based on there not being any relationship, would be 12, okay? So 40% of 30 is 12, and that's my expected value of male cheaters, based on these marginal values. And I can go through and do that for the whole table. So if 60% of men are not cheaters, then that would be 18 in that cell. And then I can do the same thing for women. Now I have a bigger base of women. There's more women, so I'm going to expect a higher number. But 40% of 70 cheated. If that happened, there'd be 28 women cheaters. And then there'd be 42 not cheaters, all right, in my class. So now I've constructed my expected values. That's what I would expect to see if there's no relationship between cheating and gender. It affects both of them the same way. So that's what I expect, but that may not be what actually happened. And so what I want to do now is I want to turn my attention to what I actually saw. And then I'm going to compare that observed data with my expected data to find out whether there's really a relationship or not. So if it looks exactly like this, then I'll conclude that there's no relationship between gender and cheating. But if it looks different than this, then I'm going to have to do some testing to find out whether or not there's actually a relationship between gender and cheating. So let's suppose that this is the case. And so what did I actually see? 20 men cheated and 10 did not. 20 women cheated as well and 50 did not. That's my observed data. That's my observed data. And what I'm going to do is look at the difference between each one of these cells. So I'm going to compare my number of cheaters in the men cell with my number of expected cheaters in the men cheater cell. And the same thing, then I'm going to compare these two, the women cheaters observed versus the women cheater expected, and so on. Go all the way through those 4 cells. All right, now I drew those tables for the sake of giving you the conceptual notion about what's going on. But when you do this in real life, you actually start off with your data and you construct all that expected value stuff from there. So I'm just going to go ahead and do that as if I'm starting with the data and work my way through it the way you normally would so you can see how to do the problem. I would actually start off being confronted by this data right here. I found that 20 men cheated, 20 women cheated, 10 men did not cheat, and 50 women did not cheat. All right, and then I've got to proceed to produce the expected values from this data. Okay, now how do I do that? Well, I have to construct those marginal values in order to do that, and that's pretty straightforward. I just want to see how many total cheaters I had. That's 40. Okay, and I want to see how many people who didn't cheat. I have 60, and then the total number of women is 70, and the total number of men is 30. And then the total number of people altogether is 100. Now I've got my marginal values, and I can use those to create the expected values. Okay, and how do I do that? So the percentages over here happen to be 0.4 and 0.6. Okay, so I have 0.4 here, and I just multiply that times the number on the other marginal, and it gives me the expected value. So 0.4 times 30 gives me 12 here. And then 0.4 times 70 gives me the expected value here, which is 28. Okay, and then here I got to cross these two numbers instead. So to get the expected value for this cell, so 0.6 times 30 equals 18. And then 0.6 times 70 for this cell gives me the expected value there, which is 42. Okay, I just redid the same thing that I did before. All right. Now it doesn't matter which direction you do that in. You could just as well calculate your percentages on this one over here and multiply times that, and you get the same thing. So supposing those are the percentages here. So 0.3 times 40 gives you 12. 0.7 times 40 gives you 28, and so on. You can do the same thing either way. Really what I want to know is the difference between the observed and the expected. And to do that, I'm just going to subtract the observed. This here is the observed. This is the expected, and then the difference will be down here. Okay? And the difference is 20 minus 12 is 8. Simple. Okay? And I do the same thing over here. Observed, expected, and the difference. This is negative 8, and the difference is 8. All right? So now I've done it. Now I know what the difference between the observed and the expected in each one of my types, each one of my cells is. Okay? Very straightforward. Now we need to figure out if those differences that we found are significant or not. We need to find out whether they really mean something statistically or they just can happen sort of by random. And that's what we're going to do in the very next lecture, where I'm going to introduce you to the chi-square statistic. We'll see you in just a few minutes.